In this video, I'll be going over vector databases, the problems that they solve, their components, and their use cases. When you're doing vector search, you typically have two options. The first is to use a vector database, but the second is to use an in-memory vector search solution like FAISS, which stands for Facebook AI Similarity Search. Now, these in-memory vector search libraries have one main advantage. They're faster than vector databases, but they have a slew of disadvantages. The first is that they're way too hard to deploy. In practice, if you're trying to create a large-scale deployment of one of these libraries, you likely need specialized expertise and substantial computational resources. In addition to this, it's very difficult to predict in advance how much one of these deployed instances is going to cost. Another issue is that there's no durability or crash recovery. These are not databases. They are built specifically for in-memory vector search. Another challenge is that data cannot be queried until the entire indexing process is complete, which means that if you're adding data to your in-memory vector store, you can't be making queries at the same time. This pretty much limits in-memory vector search libraries to use cases where your initial data isn't changing at all, and you're rarely adding data to it. Another issue is that in-memory vector search libraries only store vector embeddings, not the associated data objects or metadata, which means you need an additional storage solution just to store this data. This means in practice, you're maintaining two search solutions at the same time. Now, this could even have an impact on query latency because in practice, at inference time, you're making a query from two different database solutions. So what are vector databases, and what are some of the problems that we see in-memory vector search libraries that they solve? Well, vector databases are database systems specifically specialized for storing and searching vectors. Unlike traditional databases that specialize in storing text and numerical data, vector databases focus on storing high-dimensional vector data. These dimensions can be from a few hundred to thousands of dimensions. Vector databases are also optimized for vector similarity queries. This is used in recommendation systems and pattern recognition. They do this by using specialized indexing structures to optimize retrieval. Now, vector databases support high-dimensional vector data without some of the disadvantages of in-memory vector search. For example, they're much easier to deploy in practice, and there's usually a cloud solution that you could use, which is really easy to get started with. In vector databases also, you could make queries while you're adding data, which you can't really do with in-memory vector search. Vector databases also store the associated metadata of any vectors you insert, which means that when you're getting queries, you get this additional metadata without having an additional database query. This also means you could do cool things like metadata filtering, which means you could make more precise queries on your data. Now here's what a typical vector database pipeline looks like. You have your source data, which can be audio, video, text. And then you could use an embedding model to turn that into a set of vector embeddings. These are going to be your documents that you're going to insert into your vector database. Once your vector database has these documents, your application can send out a query to be processed by the same embedding model to generate a query vector embedding. This query vector embedding is going to be used to search your vector database and return the k closest neighbors, which are your query results. Typically, these query results will be processed in some way, so they're ready to display in your application. Now, there are additional optimizations that you can make to this pipeline. Some common ones include using hybrid search, which combines keyword and semantic search, and using a re-ranker, which is a smart AI model that could take your query results and re-rank them. But it's very likely that your vector database pipeline will look a lot like this in practice for most applications. KDB.AI is a vector database custom built to solve some of the hardest challenges AI developers are facing these days. It is built with latency in mind, which means you could insert new data and query it with extremely low latency, but at the same time, you could scale to billions of vectors. There's a cloud solution, which you could use to get started quickly, but you could also host the server solution on-prem if you need it. In addition to having the most essential features for a vector database, including hybrid search, very robust metadata filtering, and temporal similarity search, KDB.AI was purpose-built to process and analyze high-speed temporal and historical data at scale. Vector databases have the following components. They have vector collections or tables, which actually store your vector data and the associated metadata. You have your indexes. Indexes are data structures that sacrifice a little bit of accuracy but enable much faster vector search. An example is HNSW, or Hierarchical Navigable Small Worlds. Vector databases also have similarity metrics, which just compare vectors. Common choices for similarity metrics include dot product and cosine similarity. Whenever we are interacting with our database in some way, we're using the API, even if it's indirectly through a Python client. So what are some use cases for vector databases? Whenever you're building AI applications with embeddings, including semantic search and information retrieval, vector databases are usually a really good fit. Also, if you're doing recommendations and personalization, for example, let's say your user is reading an article or seeing an image, you could recommend similar articles or images to them with a vector database and similarity search. Another use case is anomaly detection and similarity-based analytics. If you have some data and you want to test whether it's an anomaly, you could look at the other data in your vector database and see if it's similar. And if it's not similar at all to your previous data, it's likely an anomaly. Now, if you're trying to decide whether you need a vector database or not, here are some times when you do need to use a vector database likely. One is when you have unstructured data you want to search. This could be text, images, audio, video, any kind of unstructured data that you could embed. So you likely also need a vector database if you're querying data by similarity rather than exact matches, which means that there's several options that could be correct that need to be ordered in some way. But if you need an exact match, which means you need the answer to fit a certain criteria, then a traditional database might be a better fit for your particular problem. Now, if you're rapidly prototyping embedding-based applications, which means you're building some kind of search engine or RAG-based chat app, vector databases are probably the easiest way to get to production quickly. Specifically, KDB.AI's cloud solution can be incorporated with very little effort. Now, if you're searching vectors at scale, and scale is different for everybody. It could be 1 million vectors, it could be 1 billion vectors. But if you're searching at a scale where it's not convenient to hold these vectors in memory, then a vector database might be the right solution for you. And finally, if query latency is much more important than insertion latency, there are other solutions that might work if query latency is not that important, but if you really want to show the results to the user extremely quickly, then a vector database is built specifically for that purpose. And finally, metadata filtering. One thing vector databases are designed to do is to very effectively filter with metadata. And they do that with pre-filtering, which means they first filter all the data using the metadata filters, and then they only use the data that matches your specific criteria when you're doing vector search. And what this means in practice is that you get much faster results. In general, KDB.AI and vector DBs are powerful tools to build embedding-based applications. There are many different applications that you could build with a vector database just because it's a very robust tool. Very often you need to search unstructured data and get relevant results. It's optimized for storing and searching very high dimensional vectors, which means you could very accurately represent the semantic meaning of your data and search it effectively. And it also enables similarity search across domains. You could search text, you can search images. If you have the right embedding model, you could search audio. Vector databases are extremely robust in that they can handle all kinds of different data, including time series data. Now, in the next video, we'll be going over indexes and how choosing the right index can greatly improve your similarity search performance.